am Dr. Mohammad Rafi, Associate Professor, Department of Cybersecurity at Institute of Aeronautical Engineering. Today I want to discuss about problem solvings on SIGCHILD signal handler in a network other programming. Here is the topic is SIGCHILD signal handler. SIGCHILD means here child signal termination. What is a SIGCHILD signal? Generally, in a portable operating the system, in this the platform, portable operating system, the interface, the compliant the platform, this SIGCHILD is a signal sent by the computer program, which is operating system. It may be the Linux operating system or Windows operating system, which is sending the signal when the child process is terminates. Here, which indicate SIGCHILD signal, which indicate child process termination. So this is the symbolical representation. SIGCHILD is a symbolical representation of a child process, the termination, sending the signal by the computer or the program. The symbolic representation, now we are writing it as a SIGCHILD. So is defined in a header file that is a signal.h. The symbolic signal names are used because signal numbers can vary across the platforms. Why? Because now number of other signal numbers signals can be sending by the computer or the program, which is child process is terminated. Now we can consider the symbolic representation is a SIGCHILD. SIGCHILD. So this is a symbolic representation. Now whenever now we are sending the signal from client to server, client to server, client mission to server mission, generally here by the computer mission. So in this the process, the child process while sending the signal, the child process will be terminated. If the child process is terminated, now we are sending it as a SIGCHILD, the symbolic representation, sequentially sending the signals. Here, what does signal child, that is a SIGCHILD signal handler, do? Generally, these SIGCHILD, which is catches or usually which is set up a part of the process initialization. Before starting the process for execution, now it can be initialized. Here they must be set before the child process is forked. Before the child process is forked, it must be initialized. Before the process, generally the processor. So the process initialization, that means here the processor which is executing. Once the signal is sent, the sequence of signals are sent to the process. These are the process by receiving the sequence of the signals which is executing the task, which is executing the jobs and transmitted depends upon that. Now after executing that the process transmitted to the end users, particular the end users. Now here is a typical SIGCHILD handler, which is a signal child handler now, which is retrieve the child the process exit status. Now child process exit the status. Here is what is a WNO hang. WNO hang. So this is a flag specification. In a Unix network the programming, WNO hang, it is a flag bit the specification. So that is waiting up to terminating the child process. That means now that wait PID should return. Wait the PID means here waiting processor ID. This the waiting the processor ID should return immediately instead of the waiting. Instead of the waiting immediately, it will be returned. If there is no child process is ready to be noticed. That means wait PID. Wait the PID now, which is a wait for a specific child process to end. That is a wait to PID. That is a wait processor ID. Now which is waiting for child process is end or child process is a terminate. So this is about the wait PID. Here is now the question is the problem is statement express the version of the SIGCHILD the signal handler that calls wait. Whenever it is calling to wait here, now what type of the version we are utilizing? What type of this the version we are utilizing for signal handler? Signal handler means generally we are sending the signals to the client by the computer program. By the computer program only now we are sending the signals. For example, here now in a ATM machine is a computer programmed. Now once if you withdraw the money immediately by the computer or the program from the bank which is sending the signal. From the bank which is sending the signal. So immediately if the signal is received from the bank, ATM machine now issues the amount to the customer. So this is a SIGCHILD. Once the transaction is completed, now the child process will be terminated. This is the best example. So in a real time, so to handle the SIGCHILD signals, here generally SIGCHILD signals and call wait in a signal handler. Call wait in a signal handler. So you need to ensure that the signal handler is a properly registered and wait the function is called to read the child process. To read the child the process. Here is an example of how you might implement this in a C programming language by using C here. So these are all the header files, that is hash include stdio.h, hash include stdlib.h, hash include signal.ho, hash include wait.ho, hash include unistd.h. Now these are all the header files. Before going to implementing now, we can declare the header files. All the other source code that can be stored in a header files. Here signal handler are the function for the SIGCHILD. Now we are writing the signal handler function void SIGCHILD handler. Signal child handler, that is int signal numbering. Which signal number, that means which signal is going to be the terminating. SIGCHILD is nothing but it is waiting for the terminating the child process. For that now we are using the wait PID, waiting for terminating the child process, and with WNO hang to read the child process. While the condition is while wait PID waiting returning, while wait PID if it is -1 which is return the termination, return the other process, null the arguments WHON. So all these are the arguments. Now if it is greater than or equals to true 0, now we can evaluate the main other function. So int main function. So the initialization is a sig action, that is a signal action. Sig action, it is a signal action is a structured data type. Here is now once after initializing that signal action, now we have to set up the SIGCHILD handler. How we are for that one, the code is s.sa handler is equals to SIGCHILD handler. Now here SIGCHILD handler is assigned to the signal action. Here also sa restart or sa no child stop, now which is assigned to the signal action flag. So signal action as a flag, specific as a flag now we are going to assigning. Here is If it is signal is a empty set. Here is the signal is a empty set. Now we are addressing the signal action. SA dot S underscore mask. Just you have to address the signal actions. If signal action is a SIGCHILD ampersand SA, it is a ampersand SA means here which is addressing. But where it is the addressing, where it is that means for whom to the addressing that particular the client depends upon the signal child. Processor or the signal child null. If it is equals to -1, if this is a condition, if it is equals to -1, signal or signal action is equals to -1 here. Now the signal actions should be printed as a error. If it is 0 or the greater than or the 0, now it will be the signal action can be sent to the client. So on so particular client. And here if it is -1 now, which is exit the signal failure. Exit the failure. That means example, creating a child process. Here is creating a child as a process. That means PID underscore TPID fork as a function. The fork function can be initialized to the PID underscore TPID. Here is if PID is equals to -1, PID is equals to -1. Now fork will be the error. The process ID means -1 means here the processor which is not receiving any task, any instructions. If is the processor not receiving any instructions, now simply now we can indicate it as PID is equals to -1. Suppose if it is receiving the any signals, now we are setting PID is equals to -1 or PID or some value that is greater than 0 also. If it is executing this child process means now we are sending the signals. We are sending the signals, the printf child process. We are sending the signals and exit successful. Here is parent process. Parent process means here printf parent the process. Parent the process can be. So this is a parent to the signal SIGCHILD. Here is what we are doing main loop to keep the parent process running. Whatever the main loop now we are using that keep the parent process which is running the parent process. And while if it is 1, here is the PID is equals to 1. While 1 means PID equals to 1. Now we can pause the other processing, waiting for signal. If it is 0, while is 0 means now which is received signal and running the which is received signal and running the child process, sending the other signals from client to server by the computer programmed. If it is computer sending the signals by the computer program, then only we can perform the actions, we can complete the task. After completing the task now, it will be terminated and return to 0. Best example is a ATM mission. ATM mission here up to getting the signal from the bank account, now here which is won't dispatch the amount to customer. So it is a signal handling. It is waiting for signal. That is a waiting for other signal. Up to here, if it is the bank is not given the signal, now simply which is the process will be the pause. Fail the process. If it is fail the process means here process ID is equals to -1. If PID is equals to -1, here fail the process. That means any response not received from the bank, which is indicate. Here, the code explanation for this is signal handler. Generally, these are the function is the triggered when a SIGCHILD, the signal is received. It uses the wait, the PID, waiting process ID, with a WHO hang option. So, to the non-blocking REAP all terminated child of the process. WHO hang options can be considered to all terminated child of the process. When the all child process are the terminated, whenever the task is completed, no, then all processes, child processes will be the terminated. While wait PID is equals to -1, that is error. Now wait PID is equals to -1 means, which is P error will be that is no signals is received by the client. By the computer program, no signal is received. That is wait PID is equals to -1. If it is null, that means no signal means null. WHO hang is a flag specific the flag. If it is greater than 0, now loop, these are the loop now which ensures that all child's processes are reaped. So this is an important to prevent the zombio of the process. Here this is about the signal handler and setting up the signal handler. That is a SIG action. Signal action, how we are going to setting. When we are setting the signal action, whenever the wait the PID is equals to 1. Whenever the wait PID is equals to 1, now we can set the signal action and perform the other process. That is S.SI is a set to the address of the signal handler function. Signal handler function, which is the address and which handles the address. S.SA flag is set to SA restart and SA no child is the stop. That means here, so the signal action no child is the stop. No child is the stop. That means the process is ongoing. If the process is ongoing, so no child stop, no CLD stop, the signal will be given to the computer or the program. The process is ongoing. SA restart, which allows the certain interrupted system calls to a restarted. SA no CLD stop, which avoid the sending the SIG child, signal child, when the child process is stopped. That means if signal set is empty, so immediately now which refers the address of the signal action. Here which refers the address of the signal actions, now which is initializes the signal set to the empty, and the meaning is no signals are blocked. No signals are blocked during the execution of the handler. Here is fork and wait. Fork and wait, that means here these are the fork generally which is the receives the processing. Signaling processing can be the receives and assign the for the process generally. Here is the child the process is created with help of the fork. Once the child the process is created with help of the fork, now which will be executed. The process will be executed. The child process now, which is the print say the message and exit. After printing the message, it will be exit from the location. Here is the parent process now, which is the continuously running and will be interrupted by the the child the signal when the child process is exit. Here is main loop. The parent the process runs an infinite loop using the pause method. Now this is the pause method now, which is the waiting for the signals. Here is these are the setup. These are the setup now that the parent process repeats the child the process without creating the zombies and handles the child signals very effectively by using this setup. Here is the question. Second one question is Explain in details about the POSIX signal handling and boundary other condition. POSIX signal handling, portable operating system interface signal handling, is the fundamental mechanism in a Unix-like operating system which allowing the process to handle the synchronous event, which is understanding the POSIX signal handling. That means here, which is involves the grasping the concept of signal type. Whatever the signals now we are sending, we are receiving from by the computer program, so it will be set as a default behavior. Automatically, now the task is assigned by the fork. Now automatically it will be receives the signals and perform the task. That means here to override this the behavior using the signal handler. By using the signal handler now, so these are the signal handler, what it is doing now, which handles the sequentially. The files should be handled the sequentially. The signals can be handled sequentially. For that now we are giving the sequence number. By giving the sequence number, now we can handle this one. The key terms generally we are using signals or software interrupts. Here generally we can say it are the software interrupts sent to the process to notify if it of the event. For example, now SIGINT interrupting the signals. SIGINT now it is SIGINT is interrupting the signal. Here is the usually generated by the this command control plus C command. Here now SIGINT signal can be generated. Termination signal, sig term is a termination signal. Signal can be terminated. SIGCHILD means now kills the signal that cannot be catched or ignored. Whatever the signals are not ignored, whatever the signals are not catched, when we are not catching the signal, whenever the signal error is arised, so in this other condition we can't catch the signal. SIGCHILD, which is the status has changed. Signal changed. Here is the default actions. That means terminating each signal has predefined default actions. So that is terminating the process, ignoring the signal, and stop the process, continuing the process by using these default actions. And signal handler. Signal handler means here the functions that executes in response to specific signals. So which is allowing to process to customize their behavior. So this is the signal handler. Functions for signal handling. That is the function. The first function is a signal function. With help of this the signal the function, now it is a very simple way to register a signal handler. But now which has the less the portability and flexibility. Very less portability. That means less portability means the signal can be changes from one system to the another system by the computer or the program. So that is a very less the portability and a very less flexibility. Here is the code for this one is a wide handle inter signal, custom handling code, signal interrupt and handle. So this is the code for signals. SIG action now, which is preferred method to its robustness and additional other features will be considered. So this is the code for this one here. Struck SIG action, that is a SA declaration. Now automatically restarting with SA flag, that is equals to, which is assigned to the SA underscore restart. Here is certain interrupted system calls. Signal is empty. No additional signals are sent to the computer by the computer or the program. So blocking during the execution. Here is if any additional signal is sent, it will be blocked. And signal actions. If the signal action SIGINT SA ampersand SA null is equals to, here is a -1. Now if it is -1, which indicates the signal error. SIG pro mask, which is used to block or unblock the signal. Now By using the SIGPROMASK the function, now you can block the signal. For blocking the signal, the code implementation is sig set underscore t mask sig empty set underscore at the rate of the mask sig add set at the rate of the mask sig ent, and if SIGPROMASK that is equals to sig block ampersand, that is a here is masking to the particular address, specific address. Masking ampersand, here is the masking the particular specific address, whatever the signal block is set. If it is null, now -1, which is returns the error. Failures will be returned. That is PRR SIGPROMASK, and exit the failure. Failure operation will be exit. Signal suspended. Suspended means here, if any extra signals now we are sending, temporarily it will be replace the signal mask and waiting for the other signals. That means in a way the mask signal mask now wait for the other signals. That means now which is making into the queue. Suspended signals can be making into other queue. Here these whatever the signals now we are making into the other queue, which is these are the signals are which are waiting for ready to execution. Sig set underscore t mask. The code is signal set is empty if it is sent to the mask and wait for the other signal. Sig address set, that is ampersand mask, referring the address of that the particular other signal from the queue. Here is now we are using the other queue. With help of this other queue now we can implement the other signals. Generally we are using the other queues for implementing the signal. With help of these queues that can be implemented. Signal the suspension can be implemented. While if it is 1, now the signal will be suspended, waiting for the signal interruptions. Signal wait suspended the calling threads until one of the specified signal is derived. Here this is the code for the signal wait. Sig the set mask here into sig number sig empty set ampersand mask sig address signal set addressing ampersand mask signal is interrupted. The boundary conditions. The boundary conditions generally here BCM boundary condition mode is also a very critical condition mode. So is a mode of operations for power converts DC to AC, DC to DC. Generally these are the modes can be utilized for power conversion, especially switch mode power supply SMPS, DC-DC converter. It operates at the boundary between the continuous conducting mode, and that is a CCM, and a discontinuous conducting mode, that is a DCM. So this is about the boundary conditions. In the context of the network, boundary conditions generally now which can frame with a set of rules and regulations and constraints, the performance can be considered. Here rules, constraints and the performance considerations that govern the interactions at the edge of the network. Here is, so these include how data is managed as it entered or leave a network or a segment or transitions between the different type of the networks or process the network interfaces. Here for this other topic, SIGCHILD signal handling, the textbook is, so this is a textbook. The textbook is Advanced Programming in the Unix Environment by Richard Stephen A. Rao. The references, the Linux Programming Interface, a Linux and a Unix system, the programming handbook by the Michael Harris. So this is about the SIGCHILD signal handler can be done in a network the programming. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.